Hi guys, welcome to 13.5 Chem Tutorial. It's our last one of our Unit 13. Huzzah, hooray, raise the roof. In this video, we're going to be talking about titrations. So get excited. There's three vocabulary terms I want to go over before we jump into titrations. The first one is molarity, which we have talked about before. Molarity is really just referring to the concentration of a solution. And screen. Okay, so the other term I want to introduce to y'all, or not maybe introduce, but review with y'all, is the word neutral, which we've talked about that in relation to pH, right? Neutral is when we have a pH of 7. But what does that mean, really? What does that actually tell us? Well, it means that the concentration, okay, or molarity, because I mean the same thing, of your hydrogen ions, okay, or your acid. So it's when the concentration of your acid or hydrogen ions, hold on. Okay, so that's when the concentration or the molarity of your acid is equal to the concentration, also known as molarity, of your base or OH ion. Do you want to say your shout out? Okay, end point is a phrase that we use when we're in the lab and we have an acid and we have a base and we mix them together just enough to get to that neutral pH. So if I have a really strong acid and a really strong base, you know what happens in a neutralization reaction, right? You have your acid, you have your base, you mix them together. What do they always form, guys? When you have a neutralization reaction and your acid and your base come together, what two things do you always form?
Oh, water and salt.
Yes! Say it loud so everyone can hear.
Water and salt.
Okay, so in the lab, when we take the acid and the base and we mix it together and we get the two neutral products, water and salt, we get that pH of 7. So when our solution becomes neutral, that's called the end point because we're at our final destination, not like the movie. Okay, that's a good joke. So let's look at some titration that we're going to be doing. So when something is neutral, there's an awesome rule. The moles, when something's neutral, the moles of your acid will always equal the moles of your base. Okay, so when something's neutral, your moles of your acid equal your mole of your base. So when a substance is neutral, we can use this formula. Okay, why is that? Well, because M is molarity, which stands for moles over liters, and volume stands for liters. So when liters cancel out, it's just moles. See that? Same thing over here. Moles over liters is this formula, and then volume is just liters. So the M1, okay, is our acid, and this is the volume of our acid, and this is the molarity, sorry, of our base, and the volume of our base. And so when you have an acid and you have a base, and they're neutral, you put them together and they're at the end point, they are neutral. We know this formula is true because, do you see how it says moles equal moles? We know the moles will equal of acid will equal the moles of the base, which makes this formula true. But this formula is only true when the substance is neutral. Okay? Because when the substance is neutral, the moles of the acid will not equal the moles of the base when it's not neutral. So this is my M of my base, and this is my volume of my base, okay? To completely neutralize, since it's at neutral, I can use this formula, okay? It has to say neutralize. And it will neutralize this much of my acid. So this is the volume of my acid. What is the concentration, which just means molarity, of my acid? So I'm just going to plug my numbers into the formula. The molarity of my acid I don't know, so I leave it Ma. The volume of my acid is 120 milliliters, and you can leave it in milliliters. You don't have to convert. Molarity of my base is 0.5, and volume of my base is 50 milliliters. So I'm going to solve for Ma. When you're solving for Ma, whatever's next to Ma needs to be removed, and so I can remove it by dividing both sides by that number. So the molarity of the acid is 0.5 times 50, which is 25, and then you do 25 divided by 125, and I get 0.2. So the molarity of my acid is 0.2 molar. Let's do another problem. How many milliliters of this much, and that's an acid, so this is the molarity of my acid. See how it has an H in it? How many milliliters, so I'm looking for volume of my acid, are required to neutralize this much of this molarity of the base. So this is the molarity of my base and the volume of my base. So I'm going to plug it in again. Here's my MA. I'm looking for my VA. Here's my MB. It's 0.100 times the volume of my B, which is 25. So I'm going to divide both sides by 0.36 to get VA by itself. And then I do 100 times 25, which gives me 2,500, and I'll divide it by 360, which gives me VA is 6.94 milliliters. Okay, so now I'm going to show you what this formula looks like in the lab with a titration. Okay, so here's my formula. MA times VA, MAVA, it says MAVA, equals MB times VB. The question is, in the lab, most of the time, we know the concentration of the base, okay, which, by the way, is MB, right? And we usually will never know the concentration of the acid. We want to find what's the molarity of the acid, okay? So we're looking for MA, which means we have to be, if we're given MB, we're given molarity, okay? Let's, like for this one, let's just pretend it's 2.0 molarity. It's 2 molar. Okay, so we're given MB. We need to measure VA and measure VB in the lab in order to solve this problem, okay? The volume of the acid is really easy. Here's how you get volume of the acid. You read the beaker, okay? For example, let's say there's a line here and the line says 150 milliliters. Then that would be our VA. So in the lab, when you're doing this, you need to read the volume of your acid, and that is your VA. Okay, so now we have VA. Now all we need is VB to solve for our molarity. So the volume of the base is not the number that is on the burette. The burette is this long, thin glassware that's used to hold liquid and drop it with just little drops like that. So it's meant to pour small amounts of liquids into a beaker. So we don't want to read the total volume of this base because we're not going to pour all the base in there. So we don't want to read the total volume. We only want to read how much volume of base we use to make it neutral. Remember, this formula, it goes to bust. We can't use it at all if this solution right here is not neutral. Okay, so we have to make this solution neutral. How are we going to make it neutral? By adding the base into it. Now you should start asking yourself the question, well, how will I know when enough base is added to make it neutral, right? So if this is my pH scale, okay, let's say we're at a pH of 2. Let's say we're at a pH of 2 and we want to be at a pH of 7. If we want to go this way on the pH scale, we have to add base, right? We learned that in another video. We have to add a base. But eventually, if we keep adding base, guess what's going to happen? It will turn into a basic solution, which we don't want. We just want it to be an exactly neutral solution. So that's why we use an indicator. We're going to use an indicator known as phenolphthalein. Phenolphthalein, I'm going to write it like this, Phen. Let's just call him Phen for short. It'll be our little nickname for phenolphthalein. Phenolphthalein inside of an acid is clear. Okay, so when we put phenolphthalein in this acid, it'll be totally clear. However, phenolphthalein, when it's in a neutral solution, is going to look a very slight, that's supposed to say slight, that is that's horrible. It's a slight pink color, okay? But when phenolphthalein is in a basic solution, it is a bright pink color. So our goal is to add enough base to make it a slightly pink color. Okay, and once we've added enough base, and then this right here is a slightly pink color, then wherever we stop with the base, so let's say we added all of this base and we made it to a slightly pink color, then this is going to be my VB. This will be the volume that I added to make it a slightly pink color. So let me kind of show you what I'm talking about with a little video. So in this video, which it's not working very well because I'm recording it, well, that sucks. He's pouring the base right now into the burette. Okay, I don't know how easily this video is showing. It looks pretty crappy to me. Okay, he's pouring the liquid into the burette. That's the thin glassware, okay? And now there's a little stopper right here where his hand is, and he can turn the stopper and allow drops of the base into the liquid. So you see how the liquid's clear, right? The liquid's clear. That's because it's an acid. There's an acid in there. But we keep adding base, and every time we add a base, you should see a slightly pink color when you add the base, right? Because base is really pink. But then when you stir it, it goes back to clear, meaning it's still an acidic solution. Okay? But eventually, he's going to add enough base to where the pink doesn't go away. And you only want to add, you want to stop exactly at the point where it stays slightly pink. That means it's exactly neutral. If you keep adding like several drops after it turns the slightly pink color, then you've in a basic solution. And it'll turn like really, really bright pink. And so your goal is to get, it's like basically if you add one drop too much, it becomes a basic solution and it's not neutral anymore. Okay, so this is a horrible video. It's like not even showing you what's happening because life hates me right now. And see, he just added one more drop and he reached the end point because this is the slightly pink color you're supposed to look for. If he kept adding one more drop or two more drops past the end point, then he would have become a basic solution and it would have turned like a really, really bright pink. So then he has to look at his burette. Okay, usually you start up here at like the 50 milliliter line, okay? And let's say he stopped the drops at 37 milliliters. So what's the volume of his base? How much did he use? Well, he used 13 milliliters. So that would be what we put in here for our volume of our base. And your station, your 13.5 lab station, has you doing this lab. So you'll want to use these notes to kind of help you walk through it. And that's it for today, guys. Remember the most important part about chemistry. What is it? Oh, I have a joke for you. Totally forgot about the joke. Okay, so in this lab titration, you have a burette, right? And when you turn the stopper, drops of the base fall down. So if I asked you, what does dubstep and titrations have in common? You could say that they both drop the base. Get it? Because of dropping. I was really excited to say that.